Benchmarking is a tool to help us visualize common fractions and their proportions. When generalized, benchmarking can help us visualize the whole, a half, and fractions of a whole. You may recall using a number line in helping you add or subtract numbers. Number lines are useful in benchmarking too. Benchmarking can be used for any set of numbers and fractions, but today we will start with a simple example of 0 to 10, where 10 represents the whole. Using benchmarking, we can more accurately approximate parts of a whole. In our example, let's say the numbers nearest to 0 are close to 0. On the other end of the number line, numbers near 10 are close to whole. If we divide the number line into two equal halves, the middle is equal to 5. Dividing each half again, we have separated the whole into 4 equal parts or quarters. What do you notice about where the red lines are sitting? Pause the video and discuss in small groups or partners where you think they might represent. Now let's use an example for benchmarking. If we select number 6, we can use benchmarking to see whether it is close to 0, close to half, or close to a whole. While we might not know exactly where it might sit on the number line, we can use benchmarking to improve our estimation. We know that 6 is greater than half of 10, our whole, so it is somewhere greater than 5. Thanks to dividing our whole into quarters, we can also see that 6 is less than 3 quarters, therefore it is less than 7.5. So using benchmarking to estimate, we can see a few things already. That the number 6 is greater than 5 but less than 7.5. It is somewhere between a half and a whole, but is definitely not close to 0. Our knowledge of fractions can also help us. We can see that 7.5 is 3 quarters, and because 6 is less than 7.5, it must be less than 3 quarters. Therefore, it must be closer to a half than it is closer to a whole. We can demonstrate this if we count how far 6 is both from our half and our whole values. 6 is closer to a half, as it is only 1 away from 5, but you need to add 4 to get to a whole, or 10. Benchmarking can also help us visualize whether a fraction is close to 0, half, or a whole. Let's look at how benchmarking can help us with fractions. Here's an example. Which do you think is closer to a whole, 5/8 or 3 quarters? Pause the video and discuss with the person next to you. At first, it's not easy to see the relationship between the two fractions. Some students might think that 5/8 is larger than 3 quarters, as it has a higher number of parts. Or they might say that 8 is greater than 4. But if we look at our number line and the denominator of each fraction, we can divide our number line into equal quarters and eighths. Let's use benchmarking to help us find out which is closer to a whole. First, we can easily see that 4/8 and 2 quarters are equivalent to a half. We can also see that 3 quarters looks like this, and 5/8 looks like this. Focusing on our eighths, we can see that we are only 1/8 away from half, but 3/8 away from a whole, so we can see that 5/8 is closer to half. But what about 3 quarters? It is both 1 quarter away from half and 1 quarter away from the whole. Like approximations, we round up to the nearest whole. With benchmarking, we can also categorize fractions as close to 0, half, or whole.
When faced with a scenario such as this, where we are asked to compare which fraction is larger, we can use another strategy called residual thinking. Residual thinking requires us to firstly think about how many more we would need to make each fraction a whole or one. The remaining amount is considered the residual. Some students might think that because 7/8 and 3 quarters only need one more part to make it a whole, it means that they're both the same. However, we are discussing fractions, not whole numbers. Whilst they both only need one more part to make them a whole, the size of the parts may not be the same. Therefore, we need to work out how large the residual or the remaining parts are. So let's visualize this by drawing two identical size shapes. They can be any shape, but for today we will draw rectangles and divide one by eighths and one by quarters. If we shade in 7/8, we can see that we only need 1/8 to make it a whole, and if we shade in 3 quarters, we can see that we only need 1 quarter to make it a whole. As you can see, 3 quarters has a larger residual than 7/8. In other words, 3 quarters requires more to become a whole than 7/8, and so 7/8 is greater than 3 quarters. We can also plot this on a number line. Using the benchmarks we recently learned, if a whole is 1, 3 quarters is located between half and 1, and 7/8 is in between 3 quarters and 1. As you can tell, 7/8 is closer to the whole or 1 compared to 3 quarters.